Triangle ABC and triangle XYZ are similar triangles. Side AC measures 3 centimeters and side XZ measures 5 centimeters. The area of triangle ABC is 45 centimeters squared. What is the area of triangle XYZ? Now for this problem, we haven't actually been given any triangles to look at, just that information. But we can go ahead and sketch these triangles to get an idea of how these triangles relate to one another. Now we know we have similar triangles, so we want to draw triangles that are the same shape, but just different sizes. So let's say that this is triangle ABC, and let's say that this triangle here is triangle XYZ. Now we've also been told that side AC measures 3 centimeters and side XZ measures 5 centimeters. We're also given the area of triangle ABC. We're told it's 45 centimeters squared. Now from this information, we're trying to find the area of the other triangle, triangle XYZ. How do we do that? Well, let's go ahead and think about what we have. We have similar triangles. We have triangle ABC and triangle XYZ. Now from that naming, we can tell that side AC corresponds to side XZ on the other triangle. We have the measurements for each of those. So if we made a ratio of those corresponding side lengths, we would have the scale factor. So let's go ahead and find that. The scale factor, that ratio. Well, if we take a look, side AC measures 3 centimeters and side XZ measures 5 centimeters. So we could get a scale factor of 3/5. Or we could write this as the ratio 3 to 5. Either way would work. Now, what could we find from the scale factor that would give us the area of this triangle? Well, let's go ahead and think a bit more about this scale factor and what we know about similar figures, to see if we can come up with a way to figure out the area of that other triangle. So instead of looking at triangles, let's go ahead and look at two other similar figures. Let's say that we have similar rectangles. And let's say that a length on this rectangle is twice the corresponding length on this rectangle. So if this width is 1, this width is 2. If this length is 3, this length is 6. So that means the scale factor is 1/2. Or we could write it as the ratio 1 to 2. Great. But remember, we're trying to find the area of this triangle. So let's go ahead and see how the areas of these rectangles relate to one another. Maybe we can figure out something there. To find the area of a rectangle, we take length times width. Here we get 3 units squared. And finding the area of the other rectangle, we get 12 units squared. Now what if we wrote these areas as a ratio, just like we did with the scale factor? Well, let's write that out and see what we get. The ratio of the areas of these rectangles. Well, we would have 3 to 12. Or we could write that as 1 to 4. Dividing each of those numbers by 4, we get this ratio. Now, how does this ratio of the areas relate to that scale factor? Well, if we took each number in that scale factor and squared each of them, we would get the ratio of the areas. Turns out that will work anytime you're working with similar figures. So maybe we could do that with our problem. So now let's take a look back at our triangles. Let's go ahead and find the ratio of the areas of those triangles. Well, to find the ratio of those areas, we just need to take this scale factor that we found and square each number. So that's exactly what we need to do. We take 3 and square it, and 5 and square it. And we get 9 to 25. This is the ratio of the areas of these triangles. Cool. But how does that help us find the area of triangle XYZ? Well, we know the area of triangle ABC, 45 centimeters squared. That 45 would correspond to this 9 in the ratio. So if we set up a ratio between the areas that we have, we would have 45 to what we're looking for, that missing value. Well, we can call that x. Well, we already have the ratio of the areas, 9 to 25. This ratio is equal to this other ratio. And if two ratios are equal, we can use them to set up a proportion. So Let's go ahead and set up a proportion and see what we get. Well, we have the ratio of the areas as 9 to 25, which we could write as the fraction 9 over 25. But we also took the areas that we were given, 45 to that value that we're looking for. We can write that as 45 over x, that missing area. And these ratios are equal, so now we have this proportion. If we can take this proportion and solve it for x, we'll have our answer. So we cross multiply to solve. We take 9 times x and get 9x, and we take 25 times 45 and get 1,125. These two things are equal, and if we focus on solving for x, we divide by 9 on both sides. And we get that x is equal to 125. And triangle ABC had an area of 45 centimeters squared. Here, this is the area of triangle XYZ, so we want to put the proper units on. That means we now have the answer we were looking for. Triangle XYZ has an area of 125 centimeters squared. So now we have found that area.